CODERS from Missouri State University presents Classroom Strategies.
Hi, this is Dave Cornelison with MSU CODERS Council, and I'm here to give you some teaching tips about some of the work we're going to be doing this year with electricity and magnetism. We've already talked about batteries and bulbs quite a bit. I show you the bulb and batteries that you might be using in your own classroom, but now we're going to talk a little bit about magnetism. And magnetism, of course, is a fascinating subject. People think about magnets and they think about finding a magnet, a permanently magnetized piece of material that they might stick to the refrigerator, and that's very common. But you should also know that amazingly enough, electricity is connected to magnetism. So if you think about the kind of circuit that we did when we were actually building over here with batteries and bulbs, we did something like this. We hooked up a pack of batteries, in this particular case AA batteries that we have in a 4-pack, which essentially becomes like a D cell, and we hook it up to a bulb like so. Now, of course, I've got to get held on here. And then we light up the bulb. We already talked about this being a stand-in for a unit of current. However, what we're going to do now is we are going to replace the bulb with something that is going to have electric current going through it and make a magnetic field. And that is this beast right here. This becomes our magnet. So you say, where's the current? The current is actually going to go through these wires here. And by going through these wires, which look like they're bare, but they're not, we'll talk more about that in a minute, I create loops of wire. And the loops of wire can either have a counterclockwise or clockwise sense. Now, when current goes in loops, amazingly enough, it produces a significant amount of magnetic field. So that's the first thing we're going to demonstrate. We want to show you that running current through a circuit configured in the right way will give us a significant magnetic field. So let's do that real quickly. Now we've got this particular kind of magnet that you have in your own kits wired in a way where we have 2 sets of loops. We're going to talk more about that in a minute also. So what we would need to do is something like this. We would take our batteries, we would make sure we're hooked to the same loop, because obviously I have 4 leads here. 2 leads going in and 2 leads coming out. And what I need to do is wire up to the same lead, and we have them marked with a piece of tape in and out. And if I do that, then of course now I'm going to have a magnetic field. Now, how am I going to check that? Well, you know, there's a lot of different ways to check it. One way I'm going to check it is I'm just going to see if it attracts metal, the right kind of metal, which we're going to talk more about in a moment. And if I disconnect the electricity, look indeed what happens. We lose the magnetic field. So that's the first thing to understand. A good way to get a magnetic field, well, one of the important ways to get one is to produce an electrical current, which we've already been doing by running current through bulbs using batteries. And then to wind our current loops in such a way. Now, one of the things you're going to look at and your students might ask about is these wires look shiny, and so they're going to think that the current can touch from one wire to another like that. But these wires actually have a baked-on enamel so that they are insulating, and what you do is you scrape the enamel off on the end using either a piece of sandpaper or some other kind of relatively rough object. And when you do that, then you can make a connection. So now the wire has a current go around and around and around and around and around and around, all the way to the other end. Now let's check another way that we can see that we have a magnetic field, because of course the students want to know, have I produced a magnetic field? So that was one way that we can attract this metal, a piece of magnetic metal, which we're going to talk about more next time. Another way, though, is to do something like this. What I'm going to do is I'm going to hook up the magnetic field here, and I've already told you that we're going to be on the one that has a tab on it. There we go. And now we have a little compass. Now it's going to be hard to see this, but if you know the compass is supposed to point north, and this one does approximately. Now the problem with these little compasses is they're very inexpensive, and so therefore they get messed up easily. But what I'm going to do is I'm going to bring this way over here, and I'm going to see that indeed it points close to north. And now watch when I bring it in close here, like this. You'll see that now north is pointing this way, which is along the magnetic field. This magnet produces a north and a south pole, just like a bar magnet does. Now, the most interesting part about that might be, you say, well, this is a little tiny magnet. How much of a magnetic field can it make? Amazingly enough, it can make a much stronger magnetic field than the magnetic field of the Earth, which is actually pretty doggone small. When you get into an MRI magnet, you're in a magnetic field that is thousands and thousands and thousands of times stronger than the Earth's magnetic field. So there are the very basics. Current produces magnetic field, and so you just put the magnet windings in the place of a bulb and you will produce a magnetic field, which we're going to talk about more in our next video. This is Dave Cornelison for CODERS Councils.